Laws of motion. In this chapter we are discussing about the Newton laws. You know Newton's first law, Newton's second law, Newton's third law. Okay. What is the definition of the Newton's first law, children? Can you remember any one of you? An object to maintain its state of rest or uniform motion until unless external force acting on a body is called Newton's first law. Once again, an object maintains uniform rest or uniform motion until unless external force acting on a body, that is called Newton's first law, isn't it? Now in this one I will give one example here. See, an object is, I am taking, it is on a horizontal surface. This is on a horizontal surface. Now the object, no one is applying the external force on that one. I am not applying any force. I am not pushing this object like this. I am not pushing like this. I am not otherwise taking up. Just it is staying. See here, the object is maintained state of rest. Object maintains state of rest unless external force acting on a body. For example, the chalks I placed on my hand. The chalks I placed on my hand. At that moment, the chalk is, with respect to the time, the object is maintaining state of rest or motion. It's maintaining state of rest. It's not going. It is not in the motion, isn't it? If I apply the external force, see here I am applying the force. Just I apply the force. At that time it is rolling on my hand. Means unless external force applied on a body, the object maintained state of rest. The object state of rest, isn't it? Okay, next one. When object is in the motion, the object is, this hand is nothing but one object. It is coming like this. It is going forward direction like this. While it is going, suddenly I applied the force like this. Now the object motion changes. The motion of the object is changes. When it is applied the external force, see the object is going like this. I stopped this one. When I am stopping means, at that moment the object is changes its state of uniform motion. That is called Newton's first law. Just I am giving once again definition. An object maintains uniform motion or state of rest unless external force acting on a body. That is called Newton's first law. This can be we can apply for the inertia. Inertia also we can apply. See here, what is inertia means? Law of inertia we have, it is inability of a body to change its state of rest or uniform motion or its direction by itself. That we can call it as the inertia, law of inertia. Once again, law of inertia means inability of a body to change its state of rest or uniform motion or its direction by itself. That is called inertia. Once again, see here, I will give one example. You got it is for 1 week holidays. Actually, your timings, you used to wake up at morning 7 o'clock. After 1 week, your mom or dad used to apply the more force. Get up. While they are saying only, you try to wake up and you go to school, isn't it? Means here external force is nothing but your mom or dad. It is nothing but your inability of your body. You don't want to go to school or you don't want to wake up at the time. At 7 o'clock you are unable to wake up. But your mom or your dad used to make you wake up. At that moment you are going to wake up and get ready going to school, isn't it? Same here, that I am giving inability of a body to change its state of rest. Actually you are on the bed, you are going to stand. That is nothing but a change of rest. You have to come to the active position. So an inability of a body to change its state of rest or uniform motion or its direction by itself. With your own interest you didn't wake up. Your mom or with the force of your mom or dad only used to wake up. So that is nothing but a That's your own interest. According to the definitions here, inability of a body to change its state of rest, or motion or direction by itself, that we can call it is law of inertia. This law of inertia 3 times. In the definition, according to the definition only I will tell you. See here, I tell you about the rest, and I told I given the motion, and one more, it is the direction. So inertia of direction, inertia of rest, first one, and second one it is inertia of motion, and third one it is inertia of direction, isn't it? Inertia of rest, inertia of motion, inertia of direction. Okay, what is inertia of rest? Inertia of rest means inability of a body, to change its state of rest by itself. Inability of a body to change its state of rest by itself is called inertia of rest. For example, I give the example for this one. You are sitting in a bus. For example, you are sitting in a one bus. The bus is initially at rest position. Now this is driver position, isn't it? Now you are sitting here inside the bus. Okay. Now bus is at rest position. Bus driver entered into the bus and he suddenly started the bus. He started bus suddenly. At that moment, what is the motion of your body? Your body will move forward direction or move backward direction, or otherwise it's maintained like that only. It is nothing but it's going backward direction. When bus suddenly moves, your body is going backward direction. You can take backward jerk like this. Means you are opposing the motion. Actually, initially your body is at rest position. So you want to continue at rest position. Your body continue at rest position. But when bus suddenly starts, you are going backward, means you are opposing the motion. You are opposing the change of state. You are opposing the change of state from rest to motion. Bus is moving forward direction, but when this is bus, your body like this. When bus is moving forward direction, means your body goes backward direction. Means by itself, your body, you are not here, inability of a body to change its state of rest by itself, that we can call it is the inertia of the rest. Okay. And next one, inertia of motion. Inability of body to change its state of motion by itself is called inertia of motion. Now, same example, same bus we can take it. I don't want rather once again bus here. Now the bus is in the motion. Now the bus is going forward direction. When bus is moving on the road, moving on the road, it is in the forward direction. Suddenly, someone came in front of the bus. Bus driver observed him and applied the brakes. When he applied the brakes, suddenly, your motion, your direction will move forward direction, backward direction, or otherwise same position. When bus drivers suddenly apply the brakes, you will fall forward direction. Means till now you are in the motion only along with the bus. When bus comes to rest position, you don't want to change your state of rest, your state of motion. You want to continue the motion. That's why only, because of that purpose only, you are falling forward direction. That is nothing but an inertia of the motion. Once again, when bus drivers suddenly apply the brakes, till then you are in the motion. but you don't want to come to the rest position. But your body it is, that's why only your body continue few seconds in the forward motion. Your body continue forward motion. See here, my body is just along with the bus, I am moving. When bus driver suddenly apply the brakes, my body is falls like this. When it is falls like this means my body is in the motion. I continue the motion few seconds. I enabled, see here, enability of your body to change its state of motion by itself. By itself. I don't want to come to the rest position. That's why only I move forward direction few seconds. Isn't it? By the external force only, I came to rest position. I came to rest position. Okay. Inability of a body to change its state of motion by itself. That is called inertia of motion. Okay. Next one. Inertia of direction. Inability of a body to change its state of direction. State of direction by itself is called inertia of direction. Where you can observe, when see here, same bus only. When bus is taking turning like this, suddenly he taking turning like this. When it is going turning like this means your position is here, your position is here. You will move, you will take right side, you fall forward, right side, this side, or otherwise you fall opposite direction. When buses take turns, you will fall along this direction or along this direction. Means when bus suddenly takes turning, you will move opposite direction. You will move opposite direction. If you have doubt, you can once you can check it when you are going in the journey. At that moment, you can observe when bus is taking turn. When you are sitting in the car, otherwise, when you are sitting in the car, when car suddenly takes turning, you will fall in opposite direction. You will fall in opposite direction. That we can call it is inertia of the direction. Inability of a body to change its state of direction by itself. That is called inertia of the direction. Okay. What is inertia? Inertia is nothing but a resistance to change. Resistance to inertia. Simple mean I am telling inertia. Inertia meaning is nothing but a resistance to change. See here inertia of the rest means when bus suddenly started, rest to motion, it is opposing. When bus is in the motion, when you apply the brakes, motion to rest, there it is opposing. Inertia of the direction, when car taking turning means it is falling in opposite direction. When you are falling in opposite direction means you are opposing this direction, you are opposing the car direction. So that is inertia means resistance to change. How you can measure the inertia? You can measure the inertia by the mass. By the mass. Mass is more. When mass is more, inertia also more. Inertia also more. When mass of the object is more, inertia also more. Mass of the object is more, inertia also more. So inertia you can measure by using of the mass. Mass is more, inertia also more. Okay. What is Newton's second law? Newton's second law. Newton's second law. Before going to Newton's second law, I want to explain about the momentum. First, I will explain momentum. What is momentum symbol? P. Momentum symbol it is P. Okay, it is the product of mass and velocity is called momentum. And mass unit is kg. And velocity units are meter per second. Velocity units are meter per second. And mass is the scalar quantity. Velocity is the vector quantity. Velocity is the vector quantity. Vector into scalar is nothing but a vector. So momentum is the vector quantity. Momentum is the vector quantity. And this is nothing but SI system units. We can write it is the dimensional quantity MLT. See here mass, capital M is represents the mass. Mass unit is nothing but a kg. Here kg is there. What is the power of the kg? 1. So 1 time that quantity is raised. Physical Here it is nothing but a dimensional formula means how many times that quantity raised, how many times that quantity raised. See here, mass is raised one time, so 1 in mass, length unit is meter, so here meter is, power it is 1, so meter is raised one time unit is second, second it is power minus 1, it is also raised by 1. So dimensional formula 1 in mass, 1 in length and 1 in time, isn't it? And change in momentum, change in momentum. Change in momentum. One object, mass of the object is m, it is moving with a velocity, initial velocity is u, it is moving with a initial velocity is u. Now after covering some distance, it attains the velocity is v, it attains the velocity is v, means this is initial at point A, initial position, at point B, final position. At point A is the initial position, at point B is final position. You know, momentum. What is the momentum? Product of mass and velocity. Momentum is product of mass and velocity. So, initial momentum is equal to mass into velocity. Here velocity is u. Okay. Final momentum is equal to mass into velocity. Here velocity is v. So initial momentum is equal to mu. Final momentum is mv. So I am writing change in momentum. Change in momentum. Change in momentum. Change in momentum dp is equal to final momentum minus initial momentum. Final momentum minus initial momentum. So dp is equal to, you can write final momentum is mv. Initial momentum is mu. Initial momentum is mu. So you can write this equation is m into v minus u. dp is equal to m into v minus u. Okay. Same now. If it is rebounds, one ball, mass is m. It is moving with a velocity u. It is moving with a velocity u, and it is, when it is touched here, when it is touched the obstacle, and it is bounce with the same velocity. It is bounce with the same velocity. See here, the ball it is moving forward direction, and it is collide with the obstacle, and it is moving in opposite direction with the same velocity. With the same velocity. Velocity is a vector quantity. Velocity is a vector quantity. So one direction if you consider positive, opposite direction should be negative. So this direction I am considering, is minus, means opposite direction. Velocity along this direction positive I take it. Okay. Now this is initial and this is final. Initial momentum at this position, initial momentum pi is equal to, what is the momentum? Product of mass and velocity. Here mass is m, velocity is minus u. So this one you can write as a minus mu. Initial momentum is minus mu. Now when it is written, now final momentum, that is pf is equal to, mass is m, velocity is u. So that is mu, isn't it? Now change in momentum is equal to, final momentum minus initial momentum. Final momentum minus initial momentum. Final momentum is mu and minus initial momentum is minus mu. Minus into minus plus mu plus mu, that equal to 2m. When object is bounce with the same velocity, at that moment change in velocity is equal to 2mu. The momentum, see here, it is one obstacle, one wall, isn't it? One object is, one ball it is projectile along this direction, one ball it is thrown with a velocity v, isn't it? At that moment it is reflected, rebounds along this direction with the same velocity. It rebounds with the same velocity. See here, object is coming along this direction. When it is collide with a wall, it will be bounce along this direction. It will be coming along this direction. Now this is making an angle with horizontal is theta at that moment, the velocity of the ball. Otherwise momentum of the ball is making an angle theta with horizontal momentum of an angle. Say the mass of the ball is mass of ball m. Mass of ball is m. We are writing it is momentum. This is initial momentum of the ball is equal to mv. What is the momentum? Product of mass and velocity. So momentum is equal, initial momentum of the ball it is mv. Now after collision it is moving with a velocity. It is moving with a velocity is v only. It is moving with a velocity v. Now this final momentum is equal to mv. See here, initial momentum is mv, final momentum is mv. Both are equal. Now this is it is making an angle theta. It is making an angle theta. At that moment, this mv can be resolved into the two components. One is horizontal component is mv cos theta. Horizontal component is mv cos theta. Vertical component is mv sin theta. mv sin theta. Same like that only. This mv final momentum also making an angle with horizontal is theta. Final momentum also making an angle with horizontal is theta. So this mv also can be resolved into two components. One is horizontal, one more it is vertical component. So horizontal component is mv cos theta. Vertical component is mv sin theta. See here, one mv sin theta is acting upward direction. One mv sin theta is acting downward direction. These are equal and opposite. So vertical components can be get cancel each other. Vertical components get cancel each other. At that moment, total momentum is equal to. See here, mv cos theta is acting along this direction. This mv cos theta also acting along this direction. Both are in same direction. You can write it is 2mv cos theta. That you can write it as a 2mv cos theta. So delta p is equal, modulus of delta p is equal to, you can write 2mv cos theta. You can go for, if ball is making an angle with vertical. See here ball is making an angle with horizontal. This is ball is making an angle with horizontal. Now it is with wall. Angle made with wall. Now this is wall. Ball it is coming along this direction, isn't it? This is horizontal. And momentum of the ball it is mv. Initial velocity of the ball is v. And it is making an angle with the ball it is theta. And after rebounds its momentum also same mv. It is moving with the same velocity, so it is momentum is mv. Here also it is making an angle with ball it is theta. At that moment this momentum can be resolved into the two components. One is horizontal component is mv cos theta. Vertical component is mv sin theta. See here, this is horizontal component and this is vertical component. Again mv can be resolved into the two components. mv cos theta, this is horizontal component mv cos theta, and this one it is vertical component mv sin theta. Now this horizontal components equal and opposite, so these two get cancel each other. Now the change in total momentum is equal to change in momentum, modulus of change in momentum is equal. These two are acting same direction. So 2mv sin theta. 2mv sin theta. See here, when object is making an angle with the horizontal, that resultant momentum is equal to 2mv cos theta. And if it is making an angle with the wall is theta, means at that moment delta p is equal to 2mv sin theta. In case of projectile motion, see here, in a projectile motion, in case of projectile motion, now one object is projectile with the initial velocity u. Mass of the object is, just I am considering the mass of object is m. Mass of object is m. What is the path of the projectile body is nothing but a parabolic. It is nothing but a parabolic path, and it is making an angle theta with horizontal. At that moment, the momentum of this body, it is resolved into the two components, that is mu cos theta. Horizontal component is mu cos theta, vertical component is mu sin theta. Horizontal component is mu cos theta, vertical component is mu sin theta. Now initial, it is nothing but an initial position at the point of projection, at initial point, what is the momentum pi is equal to, see here, mu cos theta is along the positive x-axis and mu sin theta is along the y-axis. So I am writing this is mu cos theta I plus mu sin theta j. It is nothing but a initial momentum of the body, at the highest position, this is nothing but at highest position. What at the highest position, what is the horizontal velocity? See here, at the highest position, it can having, it is only, it is nothing but a having, it is initial velocity, it is having only horizontal velocity, it cannot be having the vertical motion. See here, when object is going along the, up to from the point of projections to here, while it is going at this position, again it is moving downward direction, it is not going upwards. Here it is not having vertical motion, it is having along the horizontal direction. At the maximum highest position, velocity of the body is nothing but a zero. Along the vertical direction, velocity of the body is zero, but along the horizontal direction, it is having velocity is mu cos theta. Along the horizontal direction, it is having, it is mu cos theta. Along the vertical direction, velocity is zero. So I am writing it is final momentum is equal to mu cos theta I, and vertical direction it is the 0. Vy is equal to 0, because along the vertical direction at the maximum height, velocity of the object is 0. So that's why I am writing it is 0. How can you write this equation? Means, for your understanding, in the V is equal to Vxi plus Vyj. Here Vy is equal to 0. Here Vy is equal to 0 and Vx is equal to, why I am writing mu cos theta means along the horizontal direction, in a projectile motion along the horizontal direction, the object maintains uniform velocity at this position, at the maximum position, each and every position, velocity of the object is u cos theta. Velocity of the object is u cos theta. Now we are taking it is momentum, so that's why it is mu cos theta I have written. So final momentum is nothing but along the horizontal direction mu cos theta, along the vertical direction at highest position, velocity is 0, Vy is equal to 0. So that's why this part will becomes to 0. Now total change in momentum is equal to, how you can write, so dp is equal to final momentum minus initial momentum. Final momentum is equal to mu cos theta I, and initial momentum is equal to mu cos theta I plus minus into plus minus, so mu sin theta j. Here mu cos theta get cancelled, minus mu sin theta j, So at highest position, projectile motion, it is at highest position, at highest point, change in momentum, is equal to minus mu sin theta j. Once again I want to tell here, at maximum position, it is having vertical motion, it is having only horizontal velocity, it does not have the vertical velocity. At the highest position, vertical velocity is 0 and horizontal velocity is u cos theta. So that's why only we got this equation, isn't it? Okay. Next one, if the object is, for example, it is projectile like this, I am writing at this position. If I am writing at this position means, see here, how you can write this equation? It is moving along this direction. So with a horizontal, it is making an angle, it is theta. So u cos theta, and one more it is u sin theta. See here, the object is going along this direction and strike the ground. It strike the ground. At that moment, the velocity is nothing but a velocity direction is along this direction. Velocity direction is along this direction. So this velocity is making an angle theta with horizontal. So it can be resolved into the two components u cos theta. One more it is the u sin theta. U cos theta, u sin theta. At this position also, this u is making an angle theta. So u cos theta, horizontal component is u cos theta and vertical component is u sin theta. Now at point of projection, and this is point I am writing as at point A, where the object can reach. See here, from here to here distance you can call it as the range. Already we discussed everything. At point A, at point O, point of projection at O I am writing. So initial momentum is equal to momentum already we know it, mu cos theta, product of mass into velocity. So mass, what is the velocity along the horizontal direction? Velocity is u cos theta I. It is along the positive direction, so that's why and it is velocity, vertical velocity, mass is m and velocity is u sin theta j. J is the unit vector which is acting along the y-axis. Okay, next one, final momentum I am writing it is u cos theta is along the positive x direction. So a mass into velocity is u cos theta I. Next one it is u sin theta, vertical direction it is negative y-axis. So we can write that one, it is minus mu sin theta, otherwise for your understanding minus j. So minus into plus minus, you can write final momentum is equal to mu cos theta I minus mu sin theta j. So change in momentum is equal to final momentum minus initial momentum. Final momentum is mu cos theta I minus mu sin theta j minus initial momentum is equal to mu cos theta I and plus mu sin theta j. Final momentum is this one we have written. Initial momentum is minus into plus, this is nothing but a minus, isn't it? Minus mu cos theta get cancelled. Minus it is minus 2 mu sin theta j, isn't it? Change in momentum at the point of projection and where the object can reach, isn't it? And this is change in momentum for highest position. It is change in momentum for highest position, and this is change in momentum. It is nothing but when it is momentum is making an angle with vertical, and this one it is when momentum is making an angle with horizontal. Momentum is making an angle with horizontal. Momentum is making an angle with a vertical. So these four concepts